and welcome to today's lesson. I'm Mrs. Vaidani. Today we will explore the question, why does the moon look the way it does from Earth? Are you ready? Grab your pencil and your science journal, and let's get started. Wow, look at this photograph. What do you notice? It's another photograph of the moon. But the moon looks different than in the other photographs we observed, doesn't it? Do you notice that the moon doesn't look like a circle? It looks like a backward C. What do you wonder about this photograph? I wonder, why can't we see the full circle of the moon? Is something blocking part of the moon? Which different shapes of the moon have we observed? We have observed the moon in 3 different shapes: round, a half circle, and now C-shaped. In our last lesson, we drew 2 diagrams to help us understand whether the moon emits its own light or reflects the light from the sun. We realize the moon does not emit its own light. The moon reflects light from the sun. So let's call this diagram our reflected ray diagram. What shape did we make the moon in our diagram? We drew the moon as a complete circle. Based on the reflected ray diagram, which half of the moon is experiencing daytime? Did you say the half that faces the sun? That's right. So the other half of the moon is in darkness, where the moon cannot reflect the sun's light. I think we need to update our anchor model. Let's shade in half of the moon so that we can include daytime and nighttime on the moon. Updating this anchor model will be one of your tasks for today. But if the moon is round in our models, why does it sometimes appear to be different shapes in the sky? I wonder how the shape of the moon appears to change as it orbits Earth. Let's look at our space view model again. As you watch, think about this question. Does the portion of the moon that reflects sunlight change as the moon orbits Earth? As the moon orbits Earth, the half of the moon facing the sun is always illuminated no matter where it is during the moon's orbit. In fact, why don't we change our space view model so that we can make it even easier to see the moon's lit and dark halves? We can do this by coloring half of the ball representing the moon black. This half will represent the side of the moon that's not illuminated by the sun. Coloring half the moon will make it easier to see the moon's lit half. But like most models, our model isn't perfect. What are the limitations of our new model? Well, the real moon isn't actually colored half black, is it? Okay, let's see how the modification to our model works out. In our updated model, we can see even more clearly that the half of the moon facing the sun is always reflecting light no matter where it is during the moon's orbit. But I wonder, how do you think the moon's appearance from the perspective of Earth changes as it orbits? Let's start by looking at how the moon appears from Earth when it is on the opposite side of Earth from the sun. The side of the moon that is facing the Earth is completely illuminated by the sun, so on Earth we can see a full moon. The moon continues to orbit. What does the moon look like from the perspective of Earth at this stage of its orbit? Let's watch and see. To a person watching from Earth, only half of the moon's illuminated portion is visible. The moon looks like a half circle. Let's see how the moon's appearance continues to change as it moves along its orbit. What does the moon look like when it's between the sun and Earth? Well, in this position, no portion of the moon facing the Earth is illuminated by the sun's rays. Can we see the moon in the sky? Let's find out. No, the moon is not visible. This moon is called a new moon. Let's keep going. The moon completes another quarter portion of its orbit. What does the moon look like in this position? Let's watch the video clip to find out. The moon looks like a half circle. We've seen the moon look like a half circle before, when it was on the opposite side of the Earth from where the moon is now. But is the moon exactly the same? It's very similar, but a different half of the moon is illuminated. If we were standing on Earth and looking at the moon in this position, the right half of the moon appears to be illuminated. When the moon is on the other side of the Earth, the left half appears to be illuminated. Do you remember this photograph? I have a challenge question for you. Where is the moon in its orbit when we see this moon shape on Earth? Well, we know that when we can't see any of the light from the moon's location is here as a new moon. We also know that when the moon is here, we can see this half of the moon illuminated. So, what do you think? The moon's location has to be in between those two positions. So we think the moon with this shape will be here after the new moon. Let's watch the video clip from the new moon to see if we are correct. We are! Great work! Wow, we really added to our knowledge about the moon today. Earlier in the lesson, we updated the anchor model to show that half of the moon is always lit by the sun. We also added our new knowledge to the anchor chart under the moon section. What have we learned about the moon from the Earth perspective? The shape of the moon appears to change throughout a month. And what about the space perspective? Let's add, one half of the moon always reflects light from the sun. Updating our anchor chart will be one of your tasks for today. Let's look at our driving question board again. Wow, we have answered so many of our questions about the moon. So what questions are still unanswered about our observations of the sky? We still don't know how to explain our observations of the stars, do we? In upcoming lessons, we will turn our attention to the stars to answer the question, how can we explain our observations of stars? Let's review your tasks for today. First, update the anchor model. Second, fill in the blanks to update the anchor chart.